Welcome. We are looking at section 1.5 and we are proceeding with the end of the notes and we're jumping in at example 4. These ones get even more fun. If you thought the first ones were good, wait till you see these. So example 4 gives us the two graphs. We have F and G. And the first question says, it's really not a limit question, is it? It's really just evaluating the function. So I know how to evaluate functions. I look at the inside first. So what's g of 4? G of 4, G of 4 is 6. And then it asks that would mean then what is f of 6? F of 6. F of 6, it's not a limit question, so I don't care about left and right. What I'm focusing in on is the actual point. So I would get f of 6 equals 4. So 6 becomes my input, doesn't it? B is a limit question. So now we're evaluating at 4, and I recall, so I'm going to take and evaluate the limit as x approaches 4 of g of x. And then I'll take that result and plug it into f. That's what our composite function property says to do. We know, though, that we end up with a little bit of an issue here. F of 6 is a problem when you're talking about a limit. So I need to evaluate this just a little bit more clearly, because F, I don't want therefore, I want however, F of F at 6, let's say, that looks like fat, F at x equals 6 is not continuous. And therefore it forces us to do a little bit deeper evaluation, because remember, this really truly is a limit question. All right, so back to the limit as x approaches 4 of g of x. We got an answer out, and that answer was 6. How is it coming into 6? It's coming into 6 from below. Or in other words, something less than 6. So now I want to evaluate f at 6 from the underside, something less than 6. That I can do. 6 from something less than 6 from the left, looks like we come into 1, and 1 is our answer. And maybe, I was just wondering, maybe I should have written this as the limit as x approaches 6 from the left of f of x equals 1. That might be a little bit more appropriate to write than what I had originally scheduled out there. Okay, C, f of g of 0. This is just evaluating a function. And those are a little bit easier than evaluating a limit. G of 0. G of 0. G of 0 gives me -2. Okay, so G of 0 I know to be -2. And I take that and I plug it into the outer function, and I'm looking at f of -2. And I want not the limit information, but rather the actual point of the function. And that looks like it has a height of 1. So I get f of 1, or f of -2 equals 1. D, okay, we want to evaluate at 0, and we're going to start with g of 0. G of 0 exists. G of 0, just a minute, guys. My phone's ringing. I'm going to put you on pause here for a moment. Okay, we are back in action here. We were working on D, and I said I knew the limit of g of x of 0. G of x of 0 is -2. But then when I go over to my f of x function, my f of x function at -2, oh, we got a big jump discontinuity. So I know I'm going to have to dig deeper. So I might as well just start by analyzing left and right. correct? Because we know we're going to get stuck doing it anyway. So the limit as x approaches 0 of g of x turned out to be, what was it? 2. And it's coming in from above, right? So it is 2. I'm sorry, it's -2 from above. So that would be like -1.9-ish. You know, think of it as sometimes it helps to put a little value on that. Then now I know that f of x is discontinuous at x equals -2. So I'm going to evaluate the limit as I come into -2 from the above part, a little bit bigger than -2. And I want f of x sitting here. So if I'm coming into -2 from the above or from the right side of it, I'd be coming into like -1.9, wouldn't I? And that means I'm up here at a height of 3. So this limit turns out to be 3. I hope you're getting the hang of these. If there's a point of discontinuity, that's when you really got to start watching, you know, my inner function. How am I approaching the number, from above or from below? And that will help guide you through these. Let's do a couple more, and then you should be able to handle them on your own. I hope. So let's go with this one. So I'm going to start from the inside function, the limit as x approaches 6 from the left of 1 minus f of x. That would be, well, I could say it's the limit as x approaches 6 from the left of 1 minus the limit as x approaches 6 from the left of f of x. And the limit of 1, the limit of a constant, is the constant. And f of x, 6 from the left gets me a 1. Whoops, it's a minus, isn't it? Minus there. Now it looks like a plus. Minus equals 0. I would be coming in from above. Okay. Now, I need to look at g, don't I? The limit as x approaches 6, not 6. I can just do g of 0 because it's not so complicated, is it? 0 exists. So we can just take our 0 and plug it into the outer function g and get g of 0, what is it, -2. G is continuous, which makes this easier. G is continuous at x equals 0. And therefore, it becomes a much easier limit. All right, f. 15 minus x squared. So I'm going to erase this. Think of this as like a g of x, right? I got an inner function, and that g of x function is 15 minus x squared. So in my mind, I'm kind of thinking f, the limit as x approaches 3, I believe that looks like from the right, yep, of 15 minus x squared. So if I put in 3 plus, I would have okay, trying to figure out how to write this most clearly for you. Let's just look at that inner piece. Let's focus on 15 minus x squared. That would be 15 minus 3 plus squared, which would be something a little bit larger than 9, would give me 6. And it would be 6 from below. because I remember I was a little bit bigger than 9. So 15 minus 9 would give me something just slightly less than 6. So I'm saying 6 from below. Now, when I look at my graph of f at 6, f of x is discontinuous at x equals 6. So it'll be helpful that we knew that we were coming into 6 from underside, right? F of 6 from the left side turns out to be a 1. Just got to keep track of how you're approaching some numbers, left or right. Letter G, G of 2 minus x squared. I can think of this as my f of x function, can't I? They've just been explicit with that function. So I am going to look at the limit as x approaches 2 from the left of 2 minus x squared. That means I've got 2 minus 2 from the left squared, which makes this 2 minus something a little less than 4, which would give us negative 2 positive. Plus sign, 2 plus, right? I'm coming in from the right of 2. Something slightly bigger than 2 from right. Now, G, is it continuous at negative 2? Well, of course not. Why else would they give us the problem, right? So G is not continuous. G of x is not continuous at x equals negative 2. So I do need to pay attention. I'm going to be evaluating G at negative 2 from the right side, and that I can do because we do have branches on these. So we want 2 from the right side, 2 from the negative 2 from the right side. Looks like it's 0. All right, we got f of f. Those look fun. F of f. And we're approaching negative 2. I just want to go and look at my picture. At negative 2, oh, of course, we've got discontinuity, don't we? Oh, but we're from the left side. So we're going to be coming in from the left side of negative 2. Looks like we get an answer of negative 2 there. All right, let's start with the inner function, the limit. As x approaches negative 2 from the left of f of x, we get negative 2. And we are coming in from a little bit bigger. We're from the above side, right? So from above, which in my head means negative 2 from the right side. I'm a little bit larger than negative 2. And once again, f of x is not continuous at x equals negative 2. So now I want to take my outer function. Now I'm working on the outer function. This was the inner function. The limit as x approaches to negative 2 from the right of f of x. So now we're going to jump on the other branch. 2 from the right would be, looks like it's a 3. Okay, there we go. The homework that you're going to work on is the Skill Builder worksheet. I think there's 20 questions. Some of them will be easy and then some will get difficult, like what we just worked through. Good luck.